Greetings everyone, this is non-expert here back again with another video. Today we are going to be solving problem number 4 of the 30-day LeetCode challenge, and the problem which has been given to us is the move zeros problem. Most of you would have already encountered this problem, and by LeetCode standards I would say that this is an easy problem. To my understanding, I believe this question has been asked in interviews from Facebook, but don't quote me on that. But today, the way we're going to be proceeding with this video is that I'm going to go through the problem statement as usual, and I'm going to explain my thought process on how I would explain the approach to an interview, and then we'll try to code it out. Um, so the problem description which has been given to us is that we've been given an array nums, and we need to write a function to move all the zeros of the array to the end while maintaining the relative order of the non-zero elements. So if you look at the input array over here, so you have 0, 1, 0, 3, and 12. If you don't look at any of the zeros, the order would be 1, 3, and 12. And this is not the sorting order, this is just the order of the elements. Um, and you need to push all the zeros at the very end. So you'll have all the non-zero elements with their respective ordering, which is 1, 3, and 12. And then you have all the other zeros at the end of it. So let me just quickly copy this so that I can explain my approach. And before we sort of jump into all of that, there are a few notes which have been given to us, which are really important. The first one being that we must do this in place, which means that we need to make sure that whatever we are doing happens within that array itself. So whatever nums value that we've been given, we need to make all the operations over there. And we also need to minimize the total number of operations, which sort of goes without saying for the most optimal approach. So the way I would sort of look at this is that obviously you can see that I would require some way or form of moving the values which are non-zero to the right, or sorry, to the left, and all the zeros to the right. So to do that, we could probably have two indexes, which is an I, which can contain all the zero, or which could sort of be a placeholder for where our next zero is at, and the j value, which could be the placeholder for wherever our non-zero element resides. If that didn't make sense, that's okay. So let's just have a look at how you would sort of go about it. So, so let's say that we have our I over here, and I'm just going to write I over here, and let's just give some spacing so that it's easier for me to explain. And you have your J over here. So let's make I and J as one. We're just taking this assumption for now that, the first element is going to be the zero element and the second element is going to be a non-zero element. Or, well, even if it's zero, it doesn't really matter. So the way we would sort of go about it is that whenever you encounter something in which you have an I which is zero at this moment and J which is a non-zero element, in that case you would swap those things out. So for the very first iteration, we would just swap these things out. So one goes into the ith place and J goes into the 0th place, and then we sort of move ahead with our iteration. And as you know, J is sort of containing the next index of the non-zero element. So we need to find that next element. So we can see that the fourth element is the next non-zero element. And I also, as of now, is not in the correct place. I is pointing to a non-zero element. So we need to check for that and we need to update that as well. So if we just move both I and j and increment them by 1, well, both of them would be running irrespective to each other, but just for now you can see that if I move I, and actually let me not do that, let me say that I and j are the same point. I is right now following its rules, which is that it's residing on a 0 element, and j is residing also on a 0 element, but j needs to reside on a non-zero element. So we need to find a non-zero element, which in our case is 3. So we're going to iterate and look for that value. And when j sort of comes to that value, we need to make the same swapping operation which we sort of talked about, and that would be, hey, this thing needs to be 0 now, and this thing needs to be 3. Again, you can see that the rules are not being followed. So I is going to look for the next zeroth element, which is this guy. So I is going to get incremented. It's going to come over here. And J is also residing on a zero element, whereas it needs to reside on a non-zero element. So it's going to look for the next non-zero element and then move forward from there. And when it sort of comes together, when both of them are following the rules, we do the swapping operation again. So 12 would come over here and 0 would come over here. And our basically our exit condition would be when J has reached the limit of, or rather the length of the numbers. And that's basically the intuition behind it. It's pretty simple if you sort of think about it. Well, let's try to code this out. If you didn't understand something, it's okay. When we code it out, it's going to be much more clear. And how we usually code things out, we always start with the base condition. So the base condition would be, I would say, when you've not been given any nums, or if you've been given nums, but the length of the nums is, well, it's less than 2. In that case, you just return it, you don't do anything. And we need to have two indexes, one being the ith index and one being the jth index. I'm just going to give it 0 for now. So I'm not ready to show for LeetCode how the test cases are framed. To my assumption would be that we need to find the first element and then move forward from there. So we're going to have a simple for loop which can do for index, for num, and the entire reason why we're making this for loop is that we just want to make sure that the number that we have is I mean the ith number is starting from the 0th element. So let's just do that. Let's just say, hey, if num is equal to 0, then I needs to be equal to index, j needs to be equal to index plus 1, and we break out of the loop. So it's just a simple loop just to take care of everything else. That's the basic idea behind this thing. And what we need to do is now come up with the approach that we were talking about, how we would sort of, iterate forward. So the break condition would obviously be on the while loop, which would be while j is less than length of numbers. Pretty straightforward. Um, and and the idea behind this thing is just that when you've reached something which is a non-zero element, and there's no way to move forward, you sort of break out of the condition. It's pretty straightforward. Um, Right. So when we have that, we need to start off with our base condition, which is when index I and index j are following their own rules. So let me just comment it and write the rules. So should reside on 0, and this should reside on a non-zero element. So taking that into place, if nums of I is equal to 0, which should happen, and nums of j is not equal to 0, in that case we can perform the swapping. So as you know, in Python is pretty good at swapping things out, so we can just do this, and that will swap out the elements which are at I and at j and just move them across. And the other conditions that we need to take care of is that if the rules are not being followed. So if nums I is not equal to 0, then we increment the value of I. We try to look for the next value. And the same thing goes for the jth index, which is if nums j is well equal to 0, then we need to increment and find the next value of j. We can just make j as 1 for now, it doesn't really matter. And all the updates, as you can see over here, all those operations that we're doing are swapping operations which are happening in place inside the array. And that's basically it. We don't need to return anything because the return type is none. I don't even need to write this return. But let's just go ahead and run this code. Cool, so you can see that's running. Let's just go ahead and submit this. Hopefully this should run fine. I didn't make any mistakes. Whoops, I did make a mistake. Let me have a look at this. So we're getting a list index out of range error. Why that might be would be, well, we're handling for j, but we're not handling for I. So let's handle for I as well. And let's just run this code again. I apologize for the runtime error, which happened from time to time with everyone. But let's just go ahead and see. And cool. Yeah, so that's what we were missing out. And the way I sort of debugged that out was because, well, nums j could never be out of index because j is being handled. I could be out of index, and that might be a case where you're just going through values and you're not able to find any zeros, and well, you just keep on updating and incrementing I, and that hits the last value, and then you don't find anything, and you're still incrementing it. Um, yeah, so makes pretty sense. Uh, so that's basically it. That's the entire algorithm. And when you're going through an interview as well, my suggestion would be that you first explain the problem. I know in one of my previous videos, I didn't really do that, and I apologize for that. But in an interview, you would probably want to just break down the solution into several parts, explain your approach, and just code it out afterwards. Awesome. So that's it for today's video. If you didn't understand something, do leave it in the comment section below. I always respond to all the comments as soon as I can. And if you did like this video, do give a like and do subscribe to our channel. We are a discussion over here and we would love to have you on board with us. The problem statement and the problem description and the LeetCode link should also be in the description below. So go ahead and check that out. And if you've already subscribed, you're awesome. We all know it, and have an awesome day. Thank you.